Okay. Can you hear my voice? We will start the lab for today. So in this electrical measurement lab, we have two directions. One is hardware and another one is software. So for hardware, the experiments they are not able to conduct in the lab. We are not able to conduct the experiments to record the videos. So what we are doing in this lab, we are just explaining the experiment in the manual. And for the software, already we have the videos which we recorded. So those will be explained, and Dr. Ishad will be available. So if you have any doubts, you can clear with him regarding software. And regarding hardware, I will be taking the hardware part. So you can ask me if you have any doubts. So coming to evaluation, the evaluation criteria will be same. There will be no difference physical lab or for the virtual lab. We are following the same system. So we will be having 30 grades for the reports. Why? Because we have 10 experiments. So 10 into 3, 10 multiplied by 3, 30 marks for the reports, and 20 for the mid exam, and 10 for a written exam. So 30 plus 30, 60, and 40 for final exam. So reports 30, mid exam 20, written exam 10, and final exam 40. Total 100. Okay. So how will be these exams? So anyhow, reports you can submit through the Blackboard. Okay, in the course message, and mid exam, how it will be conducted? It will be there will be uh, 20 or 10 some multiple choice questions will be there, or some filling the blanks may be there, or multiple answer questions may be there. So you have to answer those questions, and those questions will be from the manual. So you have to read the manual properly so that you can answer the questions. Final exam also will be like that only. Okay. So now coming to the experiments. So first experiment is calibration of power supply. So what is meant by calibration of power supply, and what are the objectives of calibration? So what are the objectives of this experiment? We have to calibration of line to line variable AC voltage and line to neutral variable AC voltage, calibration of line to line fixed AC voltage and line to neutral fixed AC voltage, calibration of DC variable voltage and DC fixed voltage. So first of all, here we have to understand what is meant by calibration. So what is meant by calibration? Calibration means comparing. So what we will do here, whatever the supply voltage is coming, we have to check this voltage whether it is a normal rated voltage or under rated voltage or over voltage. Why? Because we don't need under voltage and over voltage. We want a normal voltage, normal rated voltage. So what we will do, we will compare this with the two voltmeters, which are one is standard voltmeter and another one is our testing voltmeter. So, and we will see what is the difference between the readings. If there is any difference, the difference will be taken as error. If there is no difference, the error will be 0. That's all. Okay. So now coming to the theory. So power supply users occasionally ask, why do I need to get my power supplies calibrated? So first question, what is the first question is, why do I need to get my power supplies calibrated? Why I should calibrate the power supply? The basic question. So the typical justification given for calibrating power supplies is output accuracy. So we want output accuracy. So we have to calibrate the power supplies. In other words, how well does a power supply's output setting and displayed output values compare to its actual voltage and current? So in other words, what we can say, the actual power supply when compared to the output value, whether it is actual or not. This is called calibration. Users frequently challenge this justification, especially those who actively monitor the outputs of their supplies using a voltmeter and current shunts. It's saying that some engineers will not accept this justification and they will challenge this justification. So actively monitoring a power supply's output with a meter would seem to render the need for calibration mute. But this is not the case when you consider the integrity of power supply's output. Means, suppose if we are monitoring the power supply each and every minute, so there is no need to calibrate. But what he is saying, it is better to calibrate the power supply even though you are monitoring. Power supply signal integrity is basically concerned with the correctness of generated outputs without significant alternation by noise, harmonic distortion, transients, and so on. So, what he's saying, power supply signal integrity is basically concerned with the correctness. Means how you will say that a power supply is good or a power supply is bad. So we can say this power supply is good if there is no noise, there is no harmonic distortion, there is no transients. Suppose if any one is of this is present in the power supply, we can say that it is not a good power supply. Significant is used in this definition because all power supplies exhibit some degree of alteration from outside influences such as changes in line voltage, but are designed so that these influences don't degrade the performance. So why they used this word without significant alternation means if there is some noise, some distortion, some transients, no problem. Means that noise should not be beyond a rated level. Harmonic distortion should not be high. Transient should not be more. If they are within limits, no problem. Why? Because until and unless these noise, harmonic distortion, and transients don't degrade the performance of the power supply, it will be considered as a good power supply. No problem. For DC power supplies, signal integrity is primarily concerned with PERD. So for AC power supplies, we will consider all these things: noise, harmonic distortion, transients. And for DC power supplies, we will do periodic and random deviation. Defined as, the term PERD is an acronym for periodic and random deviation and replaces the former term ripple and noise. Before, we may call them as ripple and noise. Now we are calling these ripple and noise as periodic and random deviation. Residual AC component that is superimposed on the DC output voltage or current of a power supply. So what is meant by this ripple and noise? Ripple and noise are periodic random deviation means, suppose if we add a AC voltage to a DC voltage, so how it will looks like, that is called periodic and random deviation. It is measured over a specified bandwidth with all influence and control quantities maintained constant. So how we will measure this part? It will be measured in a specific bandwidth with no influence, external influence, and we have total control quantities maintained at a constant value. Attempting to measure PERD with an instrument that has insufficient bandwidth may conceal high frequency spikes that could be determinantal to a load. So suppose if you are measuring the PERD, and if you are measuring the PERD instrument which has insufficient bandwidth, so the readings may be wrong. I think the internet is slow, so the page is still loading. No, the page is not loading. I think the internet is slow, so the page is not loading. Can you see the screen now? So this is a DC signal imposed with a AC signal. So this is known as periodical and random deviation. But
Doctor,
so yes,
no, there is no slide.
screen is not. You cannot see the screen. I am sharing the screen.
No,
Wait then.
no, Doctor, I
Yeah,
don't
let
see.
me check. Now can you see? Can you see the
No,
waveform?
Doctor, no.
No. Okay.
Yes, Doctor, we see.
Okay. Yeah. So this is a DC signal imposed with the AC signal. This is periodic and random deviation. So for AC supplies, signal integrity is mainly concerned with the THD. THD means total harmonic distortion. So how a AC power supply is defined, whether it is good or bad, it is mainly concerned with the how much is the percentage of the THD, total harmonic distortion. Harmonic distortion is described as the interference in an AC power signal created by frequency multiples of the sine wave. Means, can you understand what is meant by total harmonic distortion? Means, suppose if we have a 60 Hz signal, so we will be having, uh, suppose if we have a signal like this, if I have a frequency of see one cycle, okay, then suppose if I have another signal in this, like suppose if I have another signal in this, suppose if I have two signals here like this. Now if you see, the frequency of first signal is one cycle and the frequency of second signal is two cycles, means it is making two cycles for 1 second. Suppose this is 1 second time. So like this, now what happens, this is actual my frequency should be one cycle, but here I have another signal which is having a frequency of two hertz. So this is called harmonic in the waveform. So like this, we will have different waves. Some waves will be having three cycles like this. So if we have even number of cycles, it is called even harmonic, and if we have odd number of cycles, it is called odd harmonic. So combining all these harmonics, it is called total harmonic distortion. So that is called frequency multiples. So total harmonic distortion is used as a measure of the amount of harmonic distortion in the system. So total how much we have harmonic distortion. That is called total harmonic distortion. It's easy to ascertain from the figures how excessive PERD for DC power supplies and excessive THD for AC power supplies can compromise power supply signal integrity. which may adversely affect the operation of the circuits or devices they power. So if PERD is more in the DC and the THD is more in the AC, that will affect the operation of the circuits and devices. It may also be apparent from the above waveforms. The challenge to quantify PERD and THD using just a monitoring voltmeter and current shunts. So suppose if we think that we can measure PERD and THD using a simple voltmeter, it is not sufficient. We have more specific devices. Incorporating other test equipment such as oscilloscope to actively monitor power supply, signal integrity against power performance specifications adds a resource burden to your work. So then what we have to do, we cannot measure these with the simple voltmeter and current meter. So what we have to do, we have to install some special equipment to measure this PERD and THD. Using a oscilloscope comes with various measurements and safety issues to consider. Probe loading effects. So suppose if we are using a oscilloscope to measure the signal, first of all we have to see, is there any probe damages, probe ground lead acting as an antenna and picking up radiated noise signals, whether the wire which we are using to connect these signals and oscilloscope, whether this is acting as the antenna and is it picking any noise, non-standard load feeling noise back to the output of the supply, excessive ground loop, and need to add components such as capacitors, resistors, twisted wires, and coax to the test setup as recommended by the manufacturer to determine compliance over voltage protection bandwidth limit. So all these things we have to take care while we are measuring PERD and THD. Additionally, users would need to evaluate the monitored waveforms to determine if they are acceptable given their understanding or interpretation of the manufacturer's published specifications. So after measuring, what we have to do, we have to compare them with the actual values which are given by the manufacturer, and we have to compare whether they are matching or not. Influences from one or more of the aforementioned alternations can affect a power supply's output. So there may be so many output, I mean external disturbances which can increase the total harmonic discharge. Verifying signal integrity specifications is a normal part of calibrating power supplies. On occasion, a calibration reveals an underlying problem that could evolve into a costly failure if left unattended. So here it is a precaution. So what is saying, if you ignore anything while calibrating, that it is a small issue, it will not do anything. That may become a big issue and your total system may be affected because of that. Even worse, calibration could uncover safety issues such as faulty current limiting, loose or missing or dislodged hardware, and frayed power cards. So, if you see calibration perfectly, you can see that the safety issues, like suppose if there are hanging wires or something missing wires, so all this comes under our quality. So the proposition that active monitoring assures a power supply's performance is within all manufacturer published specifications. So as per the rule, every manufacturer should give their manufacturer data on the device. Then only people will know what is the rated voltage, rated current, how much over voltage it will withstand. All these things we have to check. Calibration minimizes a potential testing risk that you can avoid. So because of calibration, what is the use of calibration, or by what is the advantage of calibration? This will minimizes a potential testing risk. So we need not to test if we calibrate. So what are the apparatus we need to do this experiment? We need a mobile workstation, a voltmeter, a ammeter. Sorry, this is change it as ammeter. This is not voltmeter. This is ammeter. Please correct it in the manual. And we need power supply and connection leads. So what we will do here, we will take the power supply. So if you see the power supply board, it will be like this. So we will take 3 voltmeters and we will connect each phase between 1 voltmeter. So 4 and 5 we will connect to voltmeter 1, 5 and 6 we will connect to voltmeter 1, and 4 and 6 we connect to voltmeter 3. So here if you observe, we are not using the neutral. So this will be our line to line voltage. So we will measure this line voltage, and there will be a standard meter on the board which will measure the actual voltage. So what we will do, first we will connect this circuit, we will turn on the power supply, and we will adjust the line to neutral voltage to exactly 120 volts. So when you set line to neutral voltage 120, the line to line voltage will be 208. Then we will measure and record each line to line voltage, and we will return the voltage to 0, and we will turn off the supply, and we will calculate the average value of the line to line voltage. So if you see one table, you will understand what we have to measure. See, we have to connect the voltmeters between 4, 5, 5, 6 and 6, 4. We have to set the panel voltage, panel voltmeter to 120, and we have to measure the external voltmeter reading. So suppose if we have here 125. Let's suppose we got 125. So what will be the error here? It will be 125. What is the formula for to measure the error? Anybody know what is the formula to measure the error? So the formula to measure the error is actual value minus measured value. So we can say 120 minus 125. So here, suppose it is, if it is 130, then it will be 120 minus 130. And here, let's suppose the it is 120, 135. Then it will be 120 minus 135. So what will be the error here? Here the error is minus 5. Here the error is minus 10. Here the error is minus 50. So what will be the average? Here it is 120. Here you can calculate the average, and here you can calculate the average. What will be the average error? Minus 5 plus minus 10 plus 15. So it will be 30. So we are taking 3 readings. So we can have the average of minus 10. Okay. So average line to line voltage, here it is 120, and here it is 125, 130 plus 135 divided by 3, it will be 128.3. Okay, so like this we can measure the voltage and we can calculate the error. So in the next step what we will do, we will change the terminals from 4 5 to 4n, 5 6 to 5n, and 6 4 to 6n. Means if you go to the diagram, so what we will do, we will take this 4, it is connected between 4 and V. So what we will do, we will remove this wire, this voltage wire will be connected to neutral. Okay, and then suppose 5, this voltmeter is connected between 5 and this will be connected to neutral, and this voltmeter is between this is between 4 and neutral, 5 and neutral, 6 and neutral. So this voltmeter already is connected between 6, so here it will be broken and it will be connected to n. Like this we will change the circuit. Then after connecting, we will apply again 120 volts and we will measure the voltage and we will calculate the error. So here to write the report, what you can do, you can take some example values. Suppose if it is 120, you can take 125 in one case, 130 in case 135 or 140, whatever you can take, and you can calculate the error. Or if you want to make the error 0, if you take the same value 120 here, 120 here, the error will be 0. Then what we will do, we will go to the next circuit. Here what we will do, we will connect 3 voltmeters between 1 and 2, 2 and 3, and 1 and 3. We will apply a voltage of 208 and we will check the voltmeter readings and we will calculate the error. And then we will change the circuit to 1 to 2 to 1 to n, 2 to 3 to 2 to n, 3 to 1 to 3 to n. We will change the circuit and we will apply 120 volts and we will measure the voltage and we will calculate the error. Same like this, we will connect a voltmeter between 7 and n, we will apply 120 volts, we will measure the actual voltage and error. So this will be repeated till we will connect voltmeter between 8 and 10. Okay, so this will be fixed DC voltage and this will be variable DC voltage. After this, we will write a result analysis how the values of supply voltage are changed. So for each and every table, you can write one point here in the result analysis. Okay, so this is your experiment 1. So if you have any doubts, you can ask. So please respond to your attendance also. Already it will be noted down in the system, but we will take Osama. Osama is there. Tamer Abdul Khalaf is there.
Abdul Khalik, yes, doctor. I am here.
Tamer, okay. Hossam bin Hassan. Khalid Hassan. Saad Muhammad Saad. South Said.
Yes, doctor, present.
South Said, okay. Saeed Mufarra. Abdullah Khalid, Abdul Ila Abdullah,
Yes, doctor.
okay. Fahad Saad, Faisal Turki,
Yes, doctor.
I'm sorry, doctor. Did you say my name?
Faisal Turki,
Yes,
okay.
it's me, doctor.
Muhammad Salem,
Yes, doctor.
Muhammad Abdurrahman,
Yes, doctor.
Muhammad Mushabab,
Yes, doctor.
Wasim Saeed, Yazin Musa,
Yes, doctor. موجود.
8. Only 8 responded. Remaining 4 are sleeping, I think. Okay, anyhow. So this is experiment 1. Do you have any doubts? If you have any doubts, you can ask. Regarding writing the report or regarding the experiment, if you have any doubts, you can ask.
Doctor, can we go?
Osama, okay. Osama, there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 2, they have to respond. Okay. If you don't have any doubt and you have given the attendance, you can go.
Yes, doctor. I have a question
Yeah, ask.
about the exams, the hardware section. Is there any hardwaring in the final and the mid?
What? I didn't understood.
Is there any connecting in the hardware mid
No,
or
no,
final?
no, 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 no. All lectures will be online. We will explain you with the hardware equipment or with the manual or in the videos. So the exams will be only objective type. Okay.